Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is the first major exam of Calculus 1, term 251. Let us have a look and solve it together. First question, find the inverse of this function. Well, the steps to find the inverse uh, is as following. First, I replace f of x, I write it y. So y would be equal to 4 over 2x plus 3, and then we solve this equation for x. To solve it for x, I will multiply cross. So y is y over 1, and I multiply y times 2x plus 3, and 4 times 1. So 4 times 1 is 4. And then expand. So y times 2x. We need to solve it for x. So if you want, we can expand or we can divide here by y. So I can say that 2x plus 3 is equal to 4 over y. And then I take 3 to the other side, so I'll have 2x. So 4y minus 3. And then I divide by 2. Well, to divide by 2 and avoiding having a complex fraction, I will write it half times 4 over y minus 3. And now I solve it for x, so I replace x, I interchange x and y. So y would be half times 4 over x minus 3. And finally, I replace y by f inverse. So f inverse of x would be half times 4 over x minus 3. You can leave it like this, or if you can add these two fractions. This is 3 over 1, so I'll have half times 4 times 1 minus 3x, and I can multiply 2 by x. The final answer would be 4 minus 3x over 2x. This is accepted. It is not a complex fraction, and this is also okay. Is the following function even, odd, or neither? To find out, we have to find f of negative x. And f of negative x means I replace x by negative x. So I have 3 times negative x to the power 4 times square root of 2. I replace x by negative x. And now negative sign to the power 4 will be positive. So in fact, I'll have 3x to the power 4 times 2. Negative x all to the power 2 will be also x squared plus 10. And now I see whether this is equal to f of x or not. It is in fact exactly f of x. So I find that f of negative x equals f of x. This means that f is even. This is the definition of the even function. If it is not even, then I check whether it's odd. If it is not odd, then I say that it is neither. Using the definition of a derivative to find f prime. So I need to find f prime means f prime of x. And the definition says it is the limit as h approaches 0 of f of x plus h minus f of x over h. The limit is there. And f of x plus h means I go to the definition of f of x, I replace x by x plus h. So I have 2. Instead of x, I have x plus h to the power 2 plus 3. So this is f of x plus h minus f of x, which is 2x squared plus 3. And keep it in brackets because there is a minus sign outside over h. The limit is still there. I did not evaluate the limit. And now let us expand. So x plus h squared will be x squared plus 2hx plus h squared. It is not x squared plus h squared. There is a third term plus 3 and might multiply the negative sign, negative 2x squared and negative 3. So I can cancel 3 with 3, all of this over h. Now again, the limit is still there. Expand, I'll have 2x squared plus 4hx plus 2h squared. I'm multiplying 2 times the 3 terms minus 2x squared over h. And as we know, all the terms without h will disappear, and the terms remaining has h in them. So I can take h as a common factor. I'll have 4x plus 2h over h. Now I can cancel h with h, and I can replace h by 0 to have 4x, because 2 times 0 is 0 plus 4x is 4x. So this is the derivative of f of x using the definition. Evaluate the following limits. When x approaches infinity or negative infinity, the method we learned is to take the term with the highest power in the numerator over the term with the highest power in the denominator. Now I simplify x to the power 9 over x to the power 2. I subtract the powers. So I'll have x to the power 9 minus 2, which is 7. And now to find this limit, I replace x by negative infinity. Well, negative infinity to the power 7 would be negative. Infinity to the power 7 is infinity, so the answer is negative infinity. Here I have x to the power 4 times sine. And if I replace x by 0, 2 over 0 is infinity. Sine infinity does not exist because sine is oscillating between -1 and 1. So we know that we use the squeeze theorem here. We have sine 2x 2 over x. Any sign is always between -1 and 1. And to have this function between two functions, I multiply all the terms by 3x to the power 4. So 3x to the power 4 times -1, I'll have negative 3x to the power 4 less than or equal 3x to the power 4 times sine 2 over x less than or equal 1 times 3x to the power 4 is 3x to the power 4. Now, according to squeeze theorem, I have to find the limit of negative 3x to the power 4 when x approaches 0, and the limit of 3x to the power 4 when x approaches 0. And if I replace x by 0, both limits would be 0. Then by squeeze theorem says that if the limit of these two functions is the same, then the limit of what is between them, which is 3x to the power 4 times sine 2 over x when x approaches 0, is also 0. Here, if I replace x by 0, I'll have 0 over 0. I know a rule that says limit sine theta over theta when theta approaches 0 is 1. So I have here sine 2x. I need 2x below. So if I notice that x squared minus 2x can be factored. I can take x outside, so I'll have x minus 10. And now this limit, I can write it as follows. I can write it sine 2x over x times 1 over x to the power minus 10. And now I need to use this fact, so I need 2 here. So I'll multiply 2 here. So 2 over 2 is 1. So now the limit of 2 is 2. The limit of this is 1. And if I replace x by 0 here, the limit of 1 over x minus 10 as x approaches 0 would be 1 over negative 10. And multiplying these three numbers, I get negative 2 over 10 or negative 1 over 5. So that's the limit. Study the continuity of this function at x equals 1. Well, the function would be continuous at x equals 1 if the limit of f of x as x approaches 1 is equal to f of 1. So f is defined at 1 if I replace here the equality. So if I replace x by 1, negative square root of 16 over 8, that's negative 4 over 8 or negative half. So this is the value of the function. Let us see whether the limit exists. So let us find the limit as x approaches 1 from the right, because the function changes its definition around 1. So from the right, I need x greater than 1. So I'll use this definition, x squared plus 2x minus 3 over x squared minus 8x plus 7. To find this limit, I replace x by 1. I get 0 over 0. So let us factor the numerator and the denominator. When we get 0 over 0, we usually try factoring or multiplying by the conjugate. So factoring x squared plus 2x minus 3, I'll have x minus 1 times x plus 3. And factoring x squared minus 8x plus 7, I'll have x minus 1 times x minus 7. Okay, so now multiplying, I'll get this one, multiplying, I'll get this one. So now I can cancel x minus 1 with x minus 1. And if I replace x by 1, I'll have 4 over 1 minus 7, which is negative 6. So negative 2 over 3 is the limit from the right. The limit from the left of 1, I'll use this definition because x should be less than 1. To find this limit, immediately I replace x by 1. I get negative square root of 16 over 8. So this is negative 4 over 8 or negative half. So what do we get? Limit f of x when x approaches 1 from the right is not equal to the limit of f of x when x approaches 1 from the left. This means that the limit of f of x when x approaches 1 does not exist. And this means that f is not continuous at x equals 1. So study the continuity. The function is not continuous at x equals 1. Find the vertical and horizontal asymptotes of f of x. Well, to find the vertical asymptote, we put the denominator equals to 0. We solve this equation, so we take 1 to the other side, and then we apply len to both sides. Len cancels e, so we have x equals len 1 is 0. So the equation of the vertical asymptote is x equals 0. To find the equations of the horizontal asymptote, I find the limit as x approaches infinity of f of x. We said that if x approaches infinity or negative infinity, we deal with the term with the highest power up and down. So we take 2ex here and ex here and neglect the numbers. I can cancel these two, and limit 2 as x approaches infinity would be 2. So the equation of the horizontal asymptote would be y equals to 2. This is one horizontal asymptote. To find the second one, I need to find the limit as x approaches negative infinity of this function. As x approaches infinity, if I replace x by infinity, I'll get infinity over infinity. So I needed to take the highest power up and down. But now as x approaches negative infinity, if I replace x by negative infinity, e to the power negative infinity is 0. So I'll have 0 plus 4 over 0 minus 1. So also there is another horizontal asymptote with the equation y equals negative 4. So there are two horizontal asymptotes and one vertical asymptote. Evaluate the limit as x approaches infinity. Well, this is x. As x approaches infinity, the graph is going like this. It's approaching this number, which is 1. As x approaches negative 1, this is negative 1 from the right. So x is approaching negative 1 from the right. What's happening to the curve? It's going down to negative infinity. As x approaches 2, this is 2, whether x approaches 2 from the right, the graph approaches this number, which is 4. Also, if x approaches 2 from the left, the graph also approaches this number, which is 4. So the answer is 4. As x approaches 0 from the left, so approach 0 from the left, the graph is going up to 1. So the limit is 1. Find the vertical and horizontal asymptotes. This line is a vertical asymptote. So the equation of the vertical asymptote is x equals -1. Horizontal asymptote, there are two horizontal asymptotes at 1 and at 2. So the equations of the horizontal asymptotes would be y equals 1 and y equals 2. Find the values of x. This should be find the values of x where the function f is not differentiable. The function f is not differentiable if it is not continuous. So at -1, there is a vertical asymptote. The function is not continuous. So it is not differentiable there. At 0, the function again is not continuous. So at 0 also the function is not differentiable. At 1, the function is not defined, so it's not continuous. So it's not differentiable at 1. At 2, the function is continuous, but it has a corner. There is a corner there. So when there is a corner, we cannot define a unique tangent line. So the function is not differentiable at these 4 values. This was the end of the solution of the exam. Good luck.